Hello and welcome to lesson 3.5 on complex numbers. Now, we've been dealing with radicals, and so we haven't really touched on what a complex number is. In this lesson, we'll kind of dive into what a complex number is, play a little bit more with radicals and simplifying radical expressions, and then we'll perform some operations on complex numbers. But a very good place to start is, what are complex numbers? Well, here's a way to figure this out. What's something that we could not handle earlier in this course is I could not handle something like the square root of a negative. But you know that we do have some skills where we can break apart things like 4 or negative 4 into 4 times negative 1. You would agree that negative 4 is the same thing as 4 times negative 1. And we have a product rule that says these can each get their own radical. And then I'm allowed at least to simplify the piece I know. The square root of 4 is 2, but I'm still left with this piece on the end, the square root of negative 1. So what complex numbers does is says, hey, let's just take this and let's make some number system that this can equal to something. Let's call this square root of negative 1, let's call it I. So I can say I have a number 2I. Okay, we're going to make a whole number system out of any square root of negative 1 is just I, and then I can actually do some math with these things that are not defined in the real numbers. And so I can simplify a square root of a negative number by pulling out the negative and calling that square root of negative 1 I. Okay, and this is a complex number. Some people call them imaginary numbers, but more properly, they're known as complex numbers. Okay? And so we can simplify these things very much in the same way. So if I wanted to do something like the square root of negative 25, you just saw me do an example like this, but it's not hard to break it apart, to tear apart the negative part. It's basically to say negative 25 is the same thing as 25 times negative 1. Give everybody their own radical, just like we already know how to do. And then we say, oh, well, square root of 25, that's 5. Square root of negative 1, that is I. All right, so we're good to go. All right, what about if I had something like, I don't know, something like this. Square root of negative 20. Oh, well, we already know. We can break this into all the pieces we need. I could break it into 20 times negative 1. Oh, and the 20 is not a perfect square, but it breaks apart further too. I could break the 20 into the 4 times 5. And then I still have times negative 1. And they all can get their own radicals. And I can handle the pieces that I can handle. Square root of 4 is 2. I can't do anything with the square root of 5. And square root of negative 1 is I. Okay, so that's not too super duper difficult. Okay, now before I dive into operations with complex numbers, I do want to introduce you to the fact that I can write complex numbers in this way, where they have a real part and a complex part. Okay, that's just our normal real numbers, and there's some complex number added to it. Okay, so we can write them in this way, and that's what I'm going to show you for all the operations we're going to want to do. And we're going to focus on adding, subtracting, and multiplication. We want to make sure we can do that with our complex numbers. Well, I'll go ahead and tell you, adding and subtracting are really well, they're all easy, but adding and subtracting are really easy and really much the same thing. So let's do an example of each, and you will see what I mean. So let's say I give you two complex numbers, like 2 plus 3i, and I want you to add to it another complex number, like 5 plus 6i. Well, all I have to do is add like terms. And so the real pieces, the 2 and the 5, those can add together. I'm going to be annoying and show an extra step, 2 plus 5, my real pieces. And then my complex parts, 3i and 6i, positive 3i, so plus 3i and plus 6i can be combined. Okay, well 2 plus 7, that's just 9. Okay. Oh, where did I get a 7? Oh, I was thinking 2 plus 5 is 7. Sorry, this is a 5. I am crazy. Oh, let's make sure it's the right color to match. Green. Okay, and now what's 2 plus 5? Let's see if I can actually add this time. 2 plus 5 is 7. Okay, there. Sorry for the confusion. Just copied that number over wrong. All right, and 3 and 6i, 3i and 6i, I can add those because they're like terms. 3i and 6i, that would be 9i. Okay, well there, we just added our first complex number, and that's skills from like baby algebra, like the very beginnings of the simplest algebra, adding like terms. That's all we do when we add complex numbers. Well, subtracting complex numbers is not going to be very much different. So if I were to subtract some complex numbers, let's say I got 7 plus 2i minus, so a subtraction this time, and let's go with 4 minus 3i. I'm going to just turn this into an addition. This is how we did it back in the beginnings of like Algebra 1, is that we would take this subtraction sign, we would turn it into a plus sign and distribute a negative to everything in here. Okay, so here's what I mean, is I would have 7 plus 2i, and I'm going to distribute this negative to the 4, so minus 4, and this negative to the minus 3i. So negative and a negative make that a positive, or a plus 3i. And now I will just combine my like terms again. 7 minus 4. I can move faster. What's 7 minus 4? That is 3. And then positive 2i plus 3i, that is positive 5i. And so adding, subtracting, not very difficult. Well, you'll also see that multiplying's not very difficult either. And so let's do 1 or 2 examples of multiplication. So 5 plus 2i times 3. What do I want to do here? We'll go minus I. And so all we're going to do is just FOIL these out, or multiply these out like we would polynomials. 5 times 3 is 15. 5 times a negative I is negative 5i. Okay, 2i times 3. So I can multiply the numeric parts. 2i times 3 is 6i. And 2i times a negative I, that's negative 2. Now I have 2 i's, that makes I squared. Well, we haven't defined yet or discussed what I squared is, but let's think about it for a second. I is the square root of negative 1. And so if I have, sorry, if I have negative 1 squared, or the square root of negative, sorry, if I have this written out twice, this I can express it as the square root of negative 1 times the square root of negative 1. Okay? All right? So if I have that, that's one way of writing it. Let's go with maybe a better way of writing this out. So that would be negative 1 squared. Right? Now what did we just, did not mean to write. What did we just discuss like last lesson? Well, if I square a square root, what happens to it? Boom, boom, it's gone, and I'm left with just a negative 1. Okay? So I guess I went overboard showing you this step. We already defined I as the square root of negative 1. If I square a square root, the square and the square root cancel. I'm just left with negative 1. So I squared is negative 1. Okay? Does that make sense, hopefully? And it's fun. Some people make you memorize all the i's all the way up from like I squared, I to the third, I to the fourth, and it cycles over and over again through these numbers. But we're not going to mess with that. The highest we'll go for today is I squared, okay? So I squared is negative 1. So if I look at this, let's see, I have some like terms here. I have 15. Now, negative 5i plus 6i, that would be what? Positive 1i, or I. Ooh, and instead of I squared, we know that I squared is, oops, I wrote it as negative I, is negative 1. So negative 1. And so we have a little more simplifying we can do. Negative 2 times negative 1 is positive 2. Positive 2. Oh, look, I have like terms. I have 15, a plain number, plus 2. So that's 17 plus I. Okay, cool. That wasn't really too difficult to do. Let's do another one. I'm going to do a special one, okay? So the only trick here was when I get I squared, that's negative 1. I'm going to do a special one. Remember when we were rationalizing the denominator a few lessons ago? And you would want to rationalize something like this. You would have to use the conjugate, which would be the same thing with a different sign in the middle. We can also have conjugates, so ignore this for now. We could also have conjugates with complex numbers. So if I have like 2 plus 3i, and I multiply the conjugate with it, 2 minus 3i, and we can still FOIL this out, or you can remember this is a special product, but 2 times 2 is 4. 2 times a negative 3i is negative 6i. 3 times a positive 2i is positive 6i. And 3i times a negative 3i is negative 9i squared. Oh, this is why it's a special product. Remember, these pieces in the middle, they're the opposites. They're going to cancel out. So I just have 4 minus 9i squared. Well, good question here is, what is I squared? Remember, that's negative 1. So I have negative 9 times negative 1. So I have 4 plus 9, which is just 13. Ah, so that's neat. So when you multiply conjugates, you're going to cancel out all the imaginary or the complex part and just get a real number again. So that's the second place these conjugates have come up. Oops, I can't spell. Need a J. Conjugates. Okay. So that's another interesting way, but just remember that I squared is negative 1. Okay. So that's all for today. Mainly a few skills are just being able to take the square roots of negative now and getting complex numbers, and then being able to add, subtract, and multiply complex numbers. All right. Try the homework. If you have any questions, please just send me an email. I'll see you next time.